Uh, till now, what we have studied in Fourier series is what is the Euler's formula, like, and what are the constants in the Euler's formula, like A0, A1, An, and Bn, and this Euler's formula can be how can be written in the form of the different limits. Let's say this is for the C to C plus 2L, but our limits are minus L to L, or minus pi to pi, or 0 to 2L, or 0 to 2 pi. In all this situation, how can we create a Euler's formula? That is what we have studied, right? We also studied how to deal with the odd function and even function, half range sine series and cosine series. And we have solved one full question where we understood how the Fourier series is created for a given function in the range 0 to 2 pi. Okay. In today's session, before we jump into the type of question we can expect in the gate, I would like to take one more question, full complete question, but in the range of minus pi to pi, just to let you know, like, just to recall the stuff, and then we will see from gate perspective what kind of questions you can expect. Okay, so it's like typical question. This how they will not ask from gate, because this is a very big question. But for your understanding the overall procedure in this question, um, we are studying it. Okay. Also, this today's session will be shorter because we have only we already studied the theoretical part, and a few questions will solve, and after that we'll close the session. So maybe one hour session we'll have today. So let's start it now. Find the Fourier series to represent the function x minus x square from minus pi to pi. You know, when limit is minus pi to pi, it means your c is minus pi and L is pi. And you know, in the formula, cos of n pi x by L is there. So L is pi means pi will get cancelled. So that is why you got sine x and cosine x terms here. And accordingly, you know, your formulas for A0, An, and Bn will change. So your overall Fourier series, according to the Euler's formula, is A0 by 2 plus summation n is equal to 1 to infinity An cos of nx plus summation n to infinity Bn sine of nx. And now it's time to calculate the A0, An, and Bn in order to represent the given function in the form of the Fourier series, or the series in terms of sine and cosine. A0 is 1 upon pi integration minus pi to pi f of x. Okay, look at the given function. Given function can neither be, you cannot say it as an odd or even, because x is an odd function, x square is an even function, and they are in subtraction. So if you consider x and x square separately, that's fine. You can say one is odd and another one is even. But as a whole, x minus x square, you cannot comment anything like whether it's odd or even. So that is why we have to calculate a not an and bn by, let's say, direct integration. So what is f of x in this case? X minus x square. Integration of x minus x square is x square by 2 minus x cube by 3, 1 upon pi as it is, and putting the limits minus pi to pi. You will end up with a minus of 2 pi square by 3. This is your a naught. Next one is an. An is what? 1 upon pi integration minus pi to pi f of x cos of nx dx. Okay, f of x cos of nx dx. So 1 upon pi as it is, integration minus pi to pi, f of x was x minus x square cos nx dx. Okay, let's keep it. Um, so you know, let's use the formula u into v formula. Integration by parts. In by parts, you use ILATE rule, ILATE. So first you will use algebraic and then trigonometric. So your u is x minus x square function. Okay, and your cos of nx is your basically v function. Okay, we got one comment here from Yamini, minus of 2 pi cube by 3. Why cube will come, Yamini? Because you can clearly see, let's say when you put x square is equal to pi, pi square by 2 you will get, and when you put minus pi, you will get minus pi square will be pi square by 2. That will get cancelled. So only term you will have is pi cube by 3 and pi cube by 3, which is again in negative sign. So minus 2 pi cube by 3, but divided by pi you have. That's why it becomes pi square. Okay, no problem. So yeah, here I use u into v formula and solve the complete integration. You will end up with a minus 4 into minus 1 raised to the power n by n square. I'll let you know how it came. So basically, when you are solving this, your limit is minus pi to pi. Sine of n pi is 0. So all the terms in which sine is there, it is 0. So this term will become 0. This term will become 0. Only term you have is the term in between, right? And after putting pi and minus pi, you will end up with this term, which is minus 4 cos of n pi divided by n square. So now cos of n pi can be written as minus 1 raised to the power n. So cos 0 is what? Cos 0 is 1. So cos of 0 is equal to minus 1 raised to the power 0. That is 1. Cos of 1 pi is what? Cos of pi is minus 1. And that is what we will get. So cos of n pi can be written as minus 1 raised to the power n. So remember this. This is very important, let's say, rule which you have to use when you are solving the questions based on the Fourier series. So 4 times, minus 4 times, sorry, minus 1 raised to the power n divided by n square. So this is your an. In the same way, you have to find the bn, which I will explain in the next slide. So please write it down and let me know once you are done with this slide. Okay. Can I proceed to the next slide? Okay. Let me go to the next slide then. This is how you will calculate bn. Bn is 1 upon pi integration minus pi to plus pi f of x sine nx dx. What is your f of x? X minus x square. So again, you will call it as a u and this as a v. U as it is integration of v is sine integration is cos divided by n. So minus cos, sorry, minus cos of nx by n. And minus integration of differentiation of first term is what? 1 minus 2x. And integration of sine is again minus cos of nx by n. And further, if you simplify, you'll end up with this big equation. Okay. This is just a simplification part. I will not explain it. Once you put the limit, you will realize that wherever you have sine term, that will become 0 because sine pi is 0, sine of minus pi is also 0. So this term which is in between will get cancels. Okay. Also, when you put the limits, the finally you will end up with a minus 2 cos of n pi by n. And you know cos of n pi can be written as minus 1 raised to the power n, and the n is in denominator as it is. So in short, the bn can be written or represented like this. Okay. So what you do, you take the n pi, cos of n pi common from the first and third term. Okay. And write down the rest of the stuff. You will end up with minus 2 by n. Okay. So in short, basically this term will get cancels out here. So that is why n cube is not coming. When you put pi and when you put minus pi, the overall term gets cancels out, and you will end up with this term only, cos of n pi by n. Yeah, so write it down, and then we'll see if we write the a naught, an, and bn together in the equation number one, which was our Fourier series given by the Eulers, how the overall series will look like. Okay. So if bn is this, what is b1? b1 will be minus 2 into minus 1 divided by 1. b2 will be minus 2 into minus 1 square by 2. b3 will be minus 2 into minus 1 raised to the power 3 by 3, so on. So this is how you'll calculate b1, b2, b3. In previous slide, we got an, so same formula. Let's say you will using that you will calculate a1, a2, a3, and then you'll put it into the series format. Okay. Anyone have any doubt till this? Finding out the a naught, an, and bn? Feel free to ask me. Okay. This question is just for your understanding the overall picture or overall procedure to find the Fourier series. This kind of big question they'll not ask in exam. But this gives you clarity about the overall procedure. Okay, so that is why we are studying it. Okay, we got one comment here from Kunal. I think using general formula of integration is easy than using by parts. So yeah, in this case, it's your choice, Kunal. For example, um, you have x minus x square and sine term. So you may have to break this integral into two groups: x sine of nx, and second will be x square sine of nx. And then you have to solve them. Okay. Still, it is not that straightforward. Okay. Whenever two functions, algebraic function and trigonometric functions, are in multiplication, things will become complicated. In this, if you assume x sine x as one function and x square sine of nx as one another function, you still have to spend some time and solve it. Okay. And yeah, whenever the general procedure to solve the questions when you have different kind of functions together is the Eilert rule, or which is integration by parts. That is why we have this Eilert rule: algebraic, inverse, then logarithmic, algebraic, trigonometric, and exponential. So depending on what kind of functions you have in multiplication, you have to choose the order and decide u and v. So I don't think like it is also easy to solve this integral by a normal method. Okay, it will take the similar effort into here also into basically steps you are getting the answer. Okay, so if there is any specific formula you have, then it's fine. If you remember that formula, you can go ahead with that. No problem. Okay, but yeah, in some cases, you may have to end up with the by parts also. Okay. So let's go to the next slide. A naught was this, an is this, and bn is this. And this was our equation. No need to write it again. You have already written it. So what is a naught? A naught was minus 2 pi square by 3 divided by 2 will be minus pi square by 3 plus summation of all the an cos of nx term. An is what? This. So a1 will be minus 4 into minus 1. So 4 by 1, 1 square. So 4 by 1 square into cos x. Next term will be minus 4 by 2 square into cos of 2x. Third term will be 4 by 3 square into cos of 3x, and so on. Plus summation of bn sine of nx. Bn is like, bn is this minus 2 into minus 1 raised to the power 1, because we are calculating the b1. So minus 2 into minus 1 is 2. 2 by 1 into sine x. Next term will be 2 by 2 into sine of 2x. Third term will be 2 by 3 into sine of 3x, and so on. And then you simplify, and you can write it like this. Okay. Or you can take common from here. So if you take 4 common, you'll get cos of x by 1 square minus cos of 2x by 2 square plus cos of 3x by 3 square, and so on. In the second bracket, you can take 2 common. So sin x by 1 minus sin of 2x by 2 plus sin of 3x by 3 minus sin of 4x by 4, and so on. Okay. So this is the overall Fourier series will look like for the given question. Okay. So this was to just recall the overall procedure. What are the formulas for A naught, A and Bn, how the Euler's formula will look like, and the overall steps which we follow to create the Fourier series. Okay. Yeah. If it is clear, then we will move to the next slide. Please confirm once we are done with this slide. Okay. So yeah, one more question related to the half range series. Express the function f of x equal to x as a half range sine series in the limit 0 to 2. Okay, so it's a 0 to 2 half range series. They are explaining, yes, half range size series. And you know, half range series is very simplified version, which is summation n is equal to 1 to infinity bn sine of n pi x by L. L is 2 in this case, right? Because half range series starts from 0 to L. So L is 2 in this case. So only point is like you have to calculate the Bn in this case. So what is Bn formula? 2 by L integration 0 to 2 f of x sine of n pi x by L. F of x in this case is x. So 0 to 2 x sine of n pi x by 2 dx. So again, by using integration by parts, you can solve it. Okay. So integration, so x as it is, integration of sine of n pi x by 2 is minus cos of n pi x by 2 divided by n pi by 2. So this will look like this, plus differentiation of first term is 1, integration of second term is minus cos of n pi x by 2 divided by n pi by 2. So it will be 2 by n pi, and this minus minus becomes plus, and you have to integrate it one more time, which will look something like this. So this will become 4 by n square pi square. Integration of cos is sine, so sine of n pi by 2. And then you'll put the limit 0 to 2. When you put 0, sine term will become 0. Okay. And yeah, when you put 2, what will happen? X is equal to sine of n pi will also become 0. So overall, this second term will be always 0 irrespective of what you are putting, whether 0 or 2. So about the first term, 2 will get cancelled, and when you put 2 and 0, you'll end up with a minus 4 of cos of n pi by n pi. You know, cos of n pi is minus 1 raised to the power n. So overall, your bn value looks something like this, which is minus 4 into minus 1 raised to the power n divided by n pi. Now 4 by pi is, you can take common, and B1 will be what? B1 will be 1 by 1 into sine of n pi by 2. B2 will be what? Minus of 1 by 2 into sine of 2 pi x by 2, and so on. So this is how you will generate the series. So this kind of questions you can expect, like which are not so big, but this is also like you can expect for 2 mark. Okay, because you're still performing some calculation which is involved with integration by parts. Okay, so please write it down. If you have any question in this, please ask me. Okay, I hope you are done with this slide. Couple of more questions we'll study now, which are a bit smaller and you can expect it from the gate point of view. Can I proceed to the next slide? Okay. Um, yeah, the coefficient of sine of nx in the Fourier series. Okay, the coefficient of sine of nx in the Fourier series expansion of f of x is equal to x square. Okay. Yeah, write it down. Question: the coefficient of sine of nx in the Fourier series expansion of f of x is equal to x square in the interval minus pi to pi. Very, um, very good question. So what you have to see is look at the limit. Limit is your minus pi to pi, right? So whenever we have the opposite signs, we have our all integrals a naught an and bn will also have the limit minus pi to pi. And whenever limits are opposite, you have to check whether they are even or odd. The function is even or odd. The function in this case is even because f of minus x is equal to f of x, right? So if it is an even function, you know, in case of even function, bn is 0 and only a naught and an will come into the picture, right? So the coefficient of sin x term will be what? It will be 0. Are you following? What is the Fourier series? Fourier series a naught by 2 plus summation n is equal to 1 to infinity en cos of nx plus summation n is equal to 1 to infinity bn sin of nx. If bn itself is 0, the coefficient bn is what? Bn is the coefficient of sin nx. So sin x sin of 2x sin 3x 4x and so on, right? So sin x coefficient will be b1, but bn itself is 0, means all the b1 b2 b3 are 0. So that is why answer in this case is 0. Okay, I hope you are following it. And why bn is 0? Because f of x is even function. Whenever we have even function, a naught and an is um, basically uh, non-zero, and bn is 0 in this case. Is it clear to you? Anyone have any doubt? Feel free to ask me. Okay. Is it clear? Can I proceed to the next slide? Okay, we got one question from Alvaz. In the question, there is a sine x. Should it be sine of nx? It's fine. See, sine of nx will ultimately end up with the sine x, sine 2x, sine 3x, sine 4x, so on, right? So first term will be b1 sine x, second term will be b2 sine 2x, third term will be b3 sine 3x. So they are asking you coefficient of sine x means b1 they are asking. Okay. So I think it's fine, whatever they are asking. We don't have to change it. Even if they say coefficient of sine of 2x or 3x and 4x, the always answer is 0 in this case. Okay. Coming towards the next question. So we have one function f of x, which is minus 2 to 2, but we don't have the same function throughout. The value of the function is 0 from minus 2 to 0, and from 0 to 2, the value is 1. Then the term independent of x in the Fourier series of f of x is, options are given 0, 1, 1 by 2, and 2. So if you know the Fourier series, what is the Fourier series? A naught by 2, summation n is equal to 1 to infinity cos of n pi x by L plus summation n is equal to 1 to infinity bn sine of n pi x by L. Both of these two terms in which summation is there are depending on the x, because cos of an x term is there in each and every part of this, or in each and every term in this case. Similarly, sine of x term will be always there, right? So basically these two terms are depending on the x. So only term which can be independent of x is this. Are you following? Only this is the term a naught by 2 is the term which is independent of x. Why? Because in this term a naught is 1 upon L integration minus L to L f of x dx. So if you integrate it with respect to x and put the limit, you don't have the variable x. So that's why a naught by 2 is the only term which is independent of x. So remember, when they are asking you to calculate the term independent of the dependent variable x in the Fourier series, your answer has to be a naught by 2. So you have to calculate a naught in this case, which will be 1 upon L integration minus L to L f of x dx. And you know your f of x is not same from minus L to L. So you are breaking the integral from minus 2 to 0 and 0 to 2. Minus 2 to 0 integration function is 0 dx, 0. So 0 into dx plus, and 0 to 2, the value of the function is 1, 1 dx. And 1 upon L, which is 1 upon 2 outside as it is. And once you solve it, you will get answer as 1. So your a naught is 1, a naught by 2 will be 1 by 2. Hence your answer is 1 by 2, because they are asking you the term independent of x. They are not asking you a naught, they are asking you complete a naught by 2. Okay, Sahil, I will repeat once again, listen carefully. In this question, they are asking us to find the term which is independent of x, means in which x term is not there. If you look into the Fourier series expansion, what are the terms you have? A naught by 2. Second term is in terms of cosine, and third term is in terms of sine. So in second and third term, you will always have cos x and sin x terms respectively. Do you agree? So x is always there. So you cannot call them as the terms which are independent of x. So the only term which is independent of x is a naught by 2. Look at the previous, let's say, solutions, what we have done. What was the a naught in this case? A naught was minus 2 pi square by 3. Here, whether x is there? No, right? Um, so look at this. Only this term is without x. In rest of all the term, you have the x. If I go back to this question, here the first term itself is without x. Rest of all the terms are with x. So a naught by 2 is the only term which is without or which is independent of x. And that is why we have calculated a naught, which is 1, and a naught by 2 is 1 by 2. Okay, so please write it down, and if you have any doubt, feel free to ask me. Okay, yeah, I hope it is clear. Now we will move towards the next slide. Yeah. Next question. If similar problem, whatever we have studied before, same problem. If f of x is 0 and 1, okay, 0 in the range minus 2 to 0, and the value of f of x is 1 in the range 0 to 2. Then the coefficient of sine of n pi x by 2 is, try to understand, the coefficient of cos of n pi x by 2. And these are the options. First of all, write down the Fourier series. Fourier series is what? A naught by 2 plus summation n is equal to 1 to infinity an cos of n pi x by 2 summation n is equal to 1 to infinity bn sine of n pi x by 2. Why 2 is coming in the denominator? Because it's a cos of n pi x by L and sine of n pi x by L, and L is equal to 2 in this case. What they are asking you is to find the coefficient of cos of n pi x by 2, means they are asking you to calculate the an in this case. They are asking you to find the an in this case. So limit of integration is minus 2 to 2. Okay. So 1 upon 2 integration minus 2 to 2 f of x cos of n pi x by L dx is your an. But your f of x is not same throughout this range. So you will break the integral into two groups, 1 upon 2 minus 2 to 2. F of x is 0 in first case, so 0 into cos of n pi x by L is 0. So I'll write directly it as 0 plus in the second range 0 to 2 f of x is 1 cos of n pi x by 2 dx will get. Integration of cos is sine of n pi x by 2 divided by n pi by 2, so which will become 2 by n pi. 1 upon 2 was outside as it is, 2 will get cancelled, and after putting the limit 0 to 2 you will end up with a 0 as answer, because when you put 0 here, cos sine of n pi you will get sine of n pi is 0. When you put 0, sine 0 is 0. So that is why 0 minus 0 is 0, divided by n pi again gives you 0, right? So in this case your an is 0 in short. Is it clear to all of you? Good. Then we'll move towards the next slide if you are done with it. Okay, I'll wait for a few more seconds and then we'll proceed to the next slide. Okay, then let's move to the next slide now. Yeah. Look at this question, what they are asking. The function f of x is minus x plus 1 in the range minus pi to 0, and the function is x plus 1 in the range 0 to pi. Okay. I'll repeat. The value of the function is minus x to 1 in the range minus pi to 0, and in the 0 to pi range it is x plus 1. What they're asking is, in the function f of x has following terms in the expansion. Options are cosine terms, sine terms, both cannot be determined. So you have to check whether you have the sine terms as well as cosine terms or not, or which of these terms are there. So f of x is known to you. You know, whenever f of x is equal to minus f of x, we call it as an even function. If function is even, a0 and an is present, bn is 0. Function is odd, f of minus x is equal to minus f of x, then bn is present in an a0 and an is non-zero. So first check whether given function can be represented as even or odd. So that is what we are doing in this case, because our limits are opposite signs. So f of minus x, what is f of minus x? Minus minus will become plus x plus 1. Okay, and you are putting x as a minus here, and x plus 1 will become minus x plus 1, and this x will become minus 1. Okay, I think I forgot to write here the symbol less than equal to. Okay, now it is correct. So I'm just replacing x with a minus x. So what is the meaning of this? 1 plus x is a function in the range minus x is less than equal to 0, and minus x is greater than equal to minus pi. What does it mean? It means that x is greater than equal to 0. Why? Because minus x is less than equal to 0 means x is greater than equal to 0, right? And if minus pi is less than equal to minus x, it means pi is greater than equal to x. Okay, so you can write it like this by removing this minus. Okay, so or in short, if you just put this minus sign to the opposite sign, opposite sides, you have to change the greater than to less than and less than to greater than, that you know, right? So using that, you can write this minus minus become plus. So pi and 0 into minus is 0. So this less than equal to become greater than equal to, this less than equal to become greater than equal to. So this is what you will get. For the second case, minus x to minus x plus 1, what they are saying, 0 is less than or equal to minus x. What does it mean? It means x is less than or equal to 0. 0 is less than or equal to, or 0 is less than minus x. Okay, 0 is less than minus x. It means 0 is greater than x, right? Because then only minus minus will become plus, and that will become 0 will become less than it. And or other way, just multiply the whole thing with a minus again and change the signs. This minus, if you bring it here, minus 0 will be 0, pi will become minus pi, and less than will become greater than. So this is how you'll get. Now, if you compare the equation number 1 and 2, both of them are same. Just first equation is kept down and the second equation is kept up. That's all. Minus 1 plus minus x plus 1, same limits you have, and x plus 1, same limits you have, right? So it means f of minus x is equal to f of x, which is our given question. Hence, It is an even function, and wherever we have the even function, a0 and an is present and bn is 0 in that case. If bn is 0 means in Fourier series expansion, all the sine terms will be 0. So it will not have sine terms. So option B is wrong. Option C is also wrong. Cannot be determined is also wrong. And hence option A is correct because you do have an present. If an is there means cos of cosine terms are there, right? So that's why option A is correct in this case. Is it clear to all of you? Anyone have any doubt? Okay. Okay. Kunal, I will explain you once again. We are checking whether the given function is even or odd. If function is even, you know, in the Fourier series, a0 and an is non-zero and bn is 0. And if function is odd, a0 and an is 0 and bn is non-zero. So it is very easy for us to conclude whether sine cosine terms are present or not. And as I said here, after putting x is equal to minus x, if f of minus x is equal to f of x, we call it as even. And that is what we are getting in this case. Okay, you're putting x is equal to minus x, you are getting it as f of minus x is equal to f of x. And hence we are concluding it as an even function. And if it is even function, a0 and an is present, bn is 0. In the Fourier series expansion, bn is 0 means all the terms which are multiplied with the sine terms are 0. Means you don't have sine term in the Fourier series. The only terms you have is a0 by 2 and an cos of nx. So you will have the cosine terms in the Fourier series, right? Because an is non-zero. So that is why the answer is cosine in this case, and sine is not the correct answer because all the bn terms are 0. b1, b2, b3, and so on. Is it clear, the procedure? Good. Okay, then I'll move towards the next slide. We have two more questions to study, this one and one more. Let's try to understand this question. In an interval 0 to pi, if the constant c is expressed as half range sine series, then the coefficient of phi sine of phi x is. I'll repeat the question. In the interval 0 to pi, if the I'll repeat the question, sorry. In the interval 0 to pi, if the constant c is expressed as half range sine series, then the coefficient of sine of phi x is. Okay. So basically, the function is constant c. F of x is a constant c, they are telling you. And they are saying it is expressed as a half range sine series in between 0 to pi. And then, if that is the case, what is the coefficient of sine of phi x? I will first show you how the half range sine series will look like. The half range sine series will look something like this. Summation n is equal to 1 to infinity bn sine of n pi x by L. Right? This is your half range sine series. And when you put L is equal to x, sorry, L is equal to pi in this case, this pi will get cancelled and you will end up with a sine of nx. So first term will be sine x, second term will be sine 2x, third term will be sine 3x, fourth term will be sine of 4x, and fifth term will be sine of 5x. That is what they are targeting, and coefficient of it will be b phi u. Okay. So they are asking you to calculate the b phi. If you calculate the bn and put n is equal to phi u, you will get the b phi. Are you following the procedure? Anyone have any doubt till this? Okay. If it is clear, then let's calculate the bn and then put n is equal to phi in order to get the b phi. Let's move to the next part of the question. Bn is equal to 2 by pi integration 0 to pi f of x sine of nx dx. 2 by pi as it is, 0 to pi f of x is a constant in this case, which you can take it out. So 2c by pi integration 0 to pi sine of nx. Integration of sine of nx is minus cos of nx by n. Put the limit 0 to pi. Okay. So minus 2c by n pi, you can take it out, and cos of n pi limit 0 to pi. Okay. Now this is your Bn. What they are asking you to do is like they are asking you the coefficient of sine of phi x, means it will be b5. When you put n is equal to 5 in this case, you will get the solution. So minus 2c by 5 pi, n is equal to 5 we are putting. Sine of n pi will be cos of 5 pi, putting the limit 0 to pi. So it will be minus 2c by 5 pi. Cos of pi, 5 pi is minus 1, cos 0 is 1. So minus minus will become minus 2. Minus 2 into minus 2 is plus 4. So 4c by 5 pi is the final answer in this case. I hope you are following it. Okay. If it is clear, then I'll move to the next slide. If you have any question, feel free to ask. Okay, we got one question here from Sahil. There is no x term in the cos, then where we put 0? Sorry, let me write it. I think I forgot to write the x term. So this is n pi x here. Okay. Cos of n pi. Not it. It is not pi. It is nx. Okay, it's not n pi. It is nx. Okay, that was the typo. Okay, so make it as n cos of n pi, and then it will be cos of phi x. In place of x, you are putting 0 and pi. Okay, Sahil? Yeah, anyone have any other question? Okay, uh, do we not have the pi in half range series within cos term? Basically, first of all, it is a half range sine series they are asking. Okay, Dinesh. And on top of it, the value of L in this case is pi. So that is why this pi got cancelled, and you have this sine of nx. Are you following it? Is this your question? Like where this pi went? So that got cancelled. Anyone else have any doubt? Okay. If no doubt, then we will move towards the next slide. One last question. In limit 0 to pi, in the limit 0 to pi, the constant term in the half range cosine series of function x square plus 2x is, I'll repeat, in the limit 0 to pi, the constant term in the half range cosine series of function f of x is equal to x square plus 2x is. Half range cosine series, how it looks like? F of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos of nx. You know the second term is not constant term because in that cos of pi x by L. In the second term, you have the x term, cos of x term, and an can also have some x term. Okay. So basically, in the second term, there are variables. You cannot call it as a constant term. So the constant term in the Fourier series, overall Fourier series, or especially in this case, they are asking cosine series is a naught by 2. Okay. So what is the ask in this question? The constant term in the half range cosine series of function is means in this function, if you write the Fourier series, half range cosine series, what is the constant term? And that is a naught by 2 only. So this is the constant term in the half range cosine series. And what is the a naught formula? A naught formula is 2 by pi integration 0 to pi f of x dx. Okay. So your target is to calculate the a naught in this case and divide with the 2, and that will be your um, let's say the constant term. Okay. So let's calculate the a naught. A naught, how will you calculate? 2 by pi 0 to infinite 0 to pi f of x is in this case is x square plus 2x dx. Integration of x square plus 2x is x cubed by 3 plus x square, and put the limit 0 to pi and get the value of the b a naught. Sorry, get the value of a naught. Okay. I'll go to the next slide to show you how can we find the value of a naught. A naught is 2 by pi integration 0 to pi f of x dx. F of x is x square plus 2x. Integration of x square is x cubed by 3. Integration of 2x is 2x square by 2. 2 will get cancelled, so x square will remain. 2 by pi is outside the bracket. Putting the limit 0 to pi is what? Pi cubed by 3 plus pi square minus 0. And then if you multiply with a pi inside, this will become pi square. Or let's say if you take pi square outside, so 2 pi you will have, because this pi will get cancelled with that, and then pi by 3 plus 1. So 2 pi into pi by 3 plus 1 is what you have the a naught. A naught by 2 is 2 will get cancelled, pi into pi by 3 plus 1. Okay, this is the final answer. So the constant term in the half range cosine series of the function x square plus 2x is pi into pi by 3 plus 1. Okay, if please let me know if you have any doubt till this. Is it clear to all of you? Okay. Yeah. If it is clear, then maybe I would like to. Okay. We have one question from Sahil. For sine, is it also same? Yes. Yeah. If it is no. Sahil, in the half range sine series, you don't have this two terms. In half range sine series, it looks like this: bn sine of n pi x by l. So the constant term in the half range sine series is 0 basically. Okay. Yeah. Some other students are also typing. Yes. Yeah, that is what I am going to explain you now, Ashish, about the so that you can start your preparation if you have not started it with a full fledged. Okay. Let me just add one slide here. Okay. So I will just explain you two major things which you should follow in order to, let's say, score good marks in GIT. Okay. So we are now just started with October month. We would have October, November, December, Jan. 4 months in your hand. Okay. So let's say 4 months roughly. Your batch started in the July. I assume that as maths is like one of the biggest subject, July, August, September, I assume at least maybe overall 40 to 50% syllabus for you. For other subjects, like in general, 50% maybe, I'm not sure, I don't know, will be completed, right? 50, 16, maybe in that range. So you guys are still in like good pace of completion of the syllabus, and it's good that you are in joined in early batches, because there will be again one batch will be in October, and then it becomes a little bit difficult for the students to let's say start preparation in the very less time and um, do it. But yeah, that is one good point for you guys, that you started it early in the July, August, September, 3 months you studied. At least you studied whatever is taught in the class with a full concentration, okay, and little bit from your side. But now in these four upcoming months, you should, if you want to have good score, you have to do it beyond the limit. Like I would expect, like daily, you have to spend yeah 4 or 5 hours at least for the gate. Okay, and in the last 2 to 3 months, it is very, very important to spend as much as possible time, because whatever you might have done very good in, let's say, July, August, September frame, and let's say at the end you are not doing putting much efforts, then there is a chance that things which you have studied in the, let's say, July or August, you might feel it as let's say little bit lost, or you'll not be able to recall all those formulas or stuff in the January, right? So you have to keep on revising. So let me focus like how you can plan. I want you to spend last 2 months, the January and February part, for revision plus solving the papers. Okay, solving the papers means solving the previous year papers. You can download. Okay, you can go to the any IIT site and download the previous year paper, or you will easily get it anywhere. Okay, you can download the PDF versions, take a printout, sit daily for 3 hours, and give as much as possible question paper. More the question papers you solve, more the marks you will get. Okay, just studying what we are teaching in the class and uh, let's say uh, solving the booklets, we will not give you 100% idea about how exam questions, let's say how to manage the time in the exam, and how to prepare from that point of view. In exam, there will be questions which are very simple. 20% questions will be very simple, that you can just read and answer it. 20% questions will be very difficult, in which you may have to spend more than the desired time which is allocated in the exam. And rest of the questions will be like moderate, in which you have to spend some time and get the answers, right? So while performing or while solving the question paper, you first start, okay, as your pace, but don't spend much time on the questions which you feel very difficult. There will be, of course, out of 65 questions, at least 6 7 questions or 8 to 10 questions you will feel difficult. Leave them. and complete the full length paper first. Try to complete it within, let's say, 2 hours or 2 hours and 20 minutes, 10 to 20 minutes. And then you rest of the time you spend on those difficult questions. And if any in any question you have doubt whether you have done some mistake or not, you can focus on it. And then in that case, you can improve your accuracy and focus on those questions which you have kept in the last. And in that way, you can manage your time, right? And that you will learn when you solve the previous year question papers by sitting 3 hours. Okay. So you sit daily in the last 2 months, okay, by solving the full length papers and track your progress. Okay. And I would suggest you to give one full length paper at least in the, let's say, in October month, October 15th or so. Try to analyze at what level you are, how much marks you are able to get in that paper. Okay. Take any previous year question paper or any mock test paper, okay, and solve it for full length, sitting in 3 hours. Check how many marks you are getting. That will give you clear idea of your level of knowledge, okay, or your level of how much preparation you have done. And then let's say you are getting 40 marks, your target is, let's say, 80 marks. You know, like you have to work hard to achieve it. Okay. Let's say you are getting 50 marks or 60 marks, then you are more closer to your target, right? So that is what, and target is different for different students, because we have students from aerospace engineering, we have students from mechanical engineering, students from EC, ECS, all of them, right? So it's a mixed batch. Look at your previous year, let's say, cut off marks of the good IITs, top 5 IITs, and that should be your target. Okay, little bit above that. Okay, 2-3 marks above that. So yeah, in maybe for mechanical student it will be very high. For some other student it will be like slightly less or so. Right? It depends, varying because in different branches, many the number of students which are appearing is different. Highest marks are different, and this varies. But in general, if you give one full length paper in the month of October, you will have a clear cut idea that I have to prepare this much. I am at this level and my target is this. And then you will get a clear idea that I have to work hard. Otherwise, we'll not be able to achieve that target, right? So you have now 2 months, which is October and November. Oh, and sorry, December. Okay, here Feb is not there, so you can say this just December mid to, or let's say December plus Jan, you can say, because in February first week itself you will have exam, right? So you don't count it. So these 2 months, try to solve like maybe 40-50 papers, full length papers. Try to solve it. Okay. You will get it previous year question papers, or anyway, you will also get the mock test papers. So bring as much as possible question paper, collect it full length papers and solve it. That is your target. And by the December itself, you should be done with a complete syllabus on your own, not from the uh, let's say from the organization or the, let's say, from the institute. It will be done anyway, but from your side also you have to complete it, right? Because whatever I'm teaching, that is not enough. You have to solve the assignment questions, okay, or you have to revise the stuff on your own again, right? So that has to be done by December on your own. So you have 3 months for it. And the last, let's say, some days of December and Jan, close to 45 days, you can say you have to. You don't have that time is not for preparation. That time is only for the revision and solving for practice. So this time is only for practice and revision. There you should not spend time studying from, let's say, beginning, right? That is not expected from you. You should complete your syllabus by December mid itself, right? On your own, I'm saying, means you have to start your preparation in parallel with what teachers are teaching in the class. And the last 45-50 days you have to spend on your own, just for the practice and revising. And if any particular topic, let's say for example in matrix you are not able to understand eigenvalues, eigenvector, then you can spend some, let's say, couple of hours to study it, and then uh, build the expertise on it, right? So that is how you can do. But it's not expected like you study until January and then expect good marks in exam without giving full length papers and sufficient revision. Okay, so whenever you are studying in these 3 months, try to start writing formulas in one book, make a formula book. Okay, and this will be very useful for you in the last 45 days of revision. So this is the one point which is one of the major point. This will make sure that you have covered all the subjects and you have collected the important points from all the subjects in this formula book. This has to be ready by the December first or second week. And solving the question paper, this is one of the major, I guess I'll tell you the point which will give you the marks. There are two, let's say I'll give one example. Two students with the same level of, or let's say one student is with a more knowledge, okay, but less practice. Another student with a moderate knowledge but more practice or and hard work, in gate exam the second student will get success. Because these days the exam is like, it is not like we have limited number of students who are let's say giving that exam, and mm, yeah, the competition is less. Now competition is very high. Your accuracy, your time management matters a lot. More practice you do, your accuracy increases. Okay, if you don't solve the maths question, you just understand the concepts and go for exam, there is more likely that you will make some mistakes in the let's say calculation part, and ultimately you will end up with the, let's say, uh, some negative marking. Okay, even if you are, let's say, aware of the concept but you are not done the practicing, it will not help you a lot. So that is why I'm saying these days the gate exam is giving good marks for the students who are doing hard work, because competition is a lot. Students are getting very good marks, and you all have to get the good marks, right? So I want you to start practicing a lot. Okay, so these are 4 months which are very important from your point, lifetime turning point of view. Some of you are preparing for PSU, some of you are preparing for let's say going into the good IITs and all, right? This is the turning point. Okay, I don't want you to, let's say, uh, think after the exam that I should have done one or two questions good in order to improve my rank, right? That time thinking about the study will not make any sense. You have enough time for preparation. 4 months are enough for preparation. Okay, but you have to be focused. You have to plan, as I said, right? By December mid, complete everything by your own, and then next 45 days you have to give for revision and solving as much as papers, and track your progress in each and every paper. Understand where you are lacking behind, and focus on those topics. Also, when the third point which I told you, these are the 2 points, major points. One is completing the syllabus and making the formula book. Second part is like in the last 45 days revising and solving the papers. And the third part is like in this month, in the October month, give one full length paper. That will give you clear cut idea at what level of preparation you are. Okay, and then your actual study starts. Until you don't know where, at what level you have prepared till now, you cannot, let's say, plan for the next part. Okay, if you are giving exam, let's say today, and you are getting 30 mark, it means you need to, or let's say 30 or less mark, it means you have to work very hard, or you have to work a lot in these next 4 months to improve it to 70, 80 marks, okay, or so on, depending on the different students, right? So as I said, just focus on these three parts. So, completing the syllabus till December month and preparing the formula book. Second is revising in last 45 days and solving as much as possible papers, full length papers. Okay, then the um, daily one full length paper, right? And on top of that, the rest of the time you can spend it for the revision and solving the, let's say, subject wise or topic wise papers, right? And as always, like if you have any difficulty, if you are feeling, let's say, you are not able to uh, uh, let's say understand some topic or not, if you are feeling down, you can feel free to reach out to me on my number on WhatsApp. Okay, we can have a discussion and I will be able to help you out. But what I'm saying is these 4 months are enough for you. You don't have to worry about like I don't have much time or so. 4 months are enough. People who are very good marks, those like who study 3 to 4 months only. And you are studying from July, you have almost completed maybe 50-60% of your syllabus. You are at a very good stage now, right? So these 4 months are more than enough for you, right? So plan accordingly, as I said, and if you have any difficulty, always feel free to reach out to me. Okay. So that's all from me today. Thank you all for listening to me, and all the best for your preparation. And yeah, we'll be in touch if you have any questions further. Thank you all. Okay, we have one question from Sahil. Today's questions are PYQS. I didn't get that short form. Um, okay, these are not previous years. Um, all of them are not previous year. Only few of them are previous years. Okay, Sahil, and majority of them is uh, like the similar questions which you can expect in the exam. Okay, yeah, thanks.